Okay, well, good day, everybody. And, well, we're here for a stoichiometry decomposition lab. So we're going to go over what lab equipment we need, the procedures, and all the really cool details. Now, I haven't decided yet what it is that you guys are going to be decomposing. It could be the Epsom salts that people can pour into the bath when they want to relax at the end of the day. It could be baking soda. It could be copper 2 sulfate pentahydrate. It depends. We'll see how things work out for that. I haven't decided, but the idea is still the same. We're going to take a chemical compound, and there's water that's attached to the main part of our compound. We're going to heat it up to make the water leave. So we're doing a dehydration reaction in this process. Okay, and we're going to check out how much water are we going to lose, and then we're going to compare it to how much water is actually in the sample itself, and then we're going to basically look at what's our percent yield for this. Okay, so what is the gear that we're going to actually need for this? Well, we're going to need the following pieces. We're going to need a pair of tongs. We're going to need our crucible, which this is where we're going to heat up our stuff. This white square is a cooling pad. It's not made of asbestos. Okay, so you don't have to worry about that. We have a ring stand here. We have a ring stand here. We have our lab burner ready to go. We have here an iron ring, and we have a clay triangle. Now remember, when you guys are turning on or turning off the gas burner, okay, if you look at this position here, it's in the off position. Now this is also the off position. When you want to turn it on full, you're going to match the handle with the nozzle where it's coming out. Okay, so just as a quick reminder here. So how do we go ahead and get started? Well, what we're going to need to do, we're going to need to take our evaporating, our crucible here, and we're going to walk over, whoops, here we go. We're going to walk over to the balances here, and if you notice, it's not on 0, so we're going to hit that to re-zero it. Now, first thing, we're going to have to measure it when it's empty. So we're going to write that down, that it's empty. Okay. After that, we're going to be adding some stuff. Okay. Now, in this case here, I'm just going to go ahead for baking soda. And let's just say I add in, okay, this amount of baking soda. That works. Okay. And I'll let you know how much of the powder you're supposed to use to heat things up. But for now, this is where we're at. Okay, let's turn this back to here. So we're going to take that and we're going to walk back to our lab station. Now, you may notice there's a clay triangle. How does that fit? Like this. That's how it's going to work. Now you're basically ready to go ahead and heat the thing up. So you're going to call the instructor over. You're going to turn on your flame like this, and then he's going to light it, and poof, now you got your flame. Okay? Now, how long are you going to need to wait for this? I think it depends on how tall the flame is, how intense the flame is, but you know, we're probably looking at maybe we're between 10 to 15 minutes, maybe. In the process, you might want to go and actually look and see what physical changes are happening in your crucible. Okay, and again, I hit the telephoto lens. All right, now we're back at that. Okay, so yeah, we're going to be looking at how long, you know, what are the changes happening in there. And let's say the time has passed and you're good to go. What do you do next? Well, that's where this comes in. And you're going to take it, you're going to bring it over to here, and you can go ahead and grab it by the side like this. Some people have tried to do it this way, okay? And you can do it that way. I would not recommend it. This is a more secure way to do it, so you're less likely to have the thing hit the floor or hit the counter, because if it spills out, your lab is ruined. And you're going to put it on here, and we're going to let that cool for a couple of minutes. Okay, now why in the world are we letting it cool for a couple of minutes? Well, if it's too hot, that might mess up our readings when we use the electronic balance. That's one thing. But we can't let it cool for too long either. Well, why? Well, remember, you heated something to get rid of the water. Once you stop heating it up and it starts to cool down, is it possible that the water can go back and, hey, you've been missing me, huh? Let's hook up. And water could be going back into the compound. So that might be another issue that we have to think about. Okay? So, just something to think about. Why would we want to not let it cool down for too long? Why is it that we need to let it cool off? All right. It's now cooled off long enough. What do we do next? We're going to go in, we're going to take our crucible, and we're going to bring that back. We're going to go ahead and we are going to bring that back and use the same balance. Okay? Use the same balance when you're doing this. And then again, you're going to write down the data, and then you're going to grab it. We're going to head on back. Set it back on here. And, well, you're pretty much done for the lab itself. Now, cleanup. We can dump this down the sink. If it's baking soda or the Epsom salts, okay, some people refer to them as bath salts. It's not the bath salts that you hear about on TV where people are getting high. That's not it at all, okay? It's magnesium sulfate with a bunch of water connected to it, okay? So one of the three compounds is going to have, they're all going to have water attached to it. So we can rinse that down the sink safely. If we cannot, I'll make arrangements as far as disposal. But pretty much I would probably would have you guys just dump that down the sink. It shouldn't be a big deal. So, recap. We are using stoichiometry to do a decomposition lab. Okay? We're going to weigh this empty. We're going to add some powder or whatever. We're going to weigh that again, so we'll have the crucible with the powder in it. We're going to bring that back. We're going to put that up here, and then we're going to heat it up for about maybe 10 minutes or so, depending. Then we're going to take that off using our tongs, because we want to be careful about this. We want to use our tongs. We're going to take that off, put that down here, and let it cool for a few minutes, okay? Don't let it cool too long, because the water can come back in and start reconnecting with the compound, and thus that gets to be an issue, okay? So then you can go take it and weigh it on the balance, and then bring it back. And there should be a change in the mass, because you're heating up water and it's being driven off. That's basically it, ladies and gentlemen. And, well, I don't know what else to say about the lab, but we're going to be using stoichiometry in this one. But now we get to see stoichiometry in action. Because, you know, we've calculated things on paper, which is our theoretical yield. The theoretical yield is what we've calculated on paper, what's going on in our perfect world. And you may remember that story I told you, in World War II about what happens when you have theoretical yield versus the actual yield, what you physically got. Okay, remember those guys in the Philippines with the gunpowder, that they didn't get the full theoretical yield. They got an actual yield, and it was very disappointing. Okay, your actual yield for this lab is what you're physically measuring out on this. Okay, That's pretty much it. I hope this helps. Take it easy, and I'll see you next time.